The peculiar interstellar traveler, Oumuamua, that once zipped through our planet, has returned, moving at an extraordinary speed toward Earth. This time, even the researchers are alarmed and issuing alerts that Oumuamua will collide in approximately 2 weeks, and nothing can prevent it. Are we confronting a possible catastrophe? Is this going to be the end of our world? Join us as we explore the urgent warning of this unusual visitor that is on the verge of impact. In 1837, an unidentified object achieved a significant cosmic milestone unnoticed by anyone. It traversed a distance of 1,000 astronomical units from the Sun. For over a century, this object continued its approach toward Earth. Ironically, no scientists detected it. It kept advancing until October 19, 2017, when a scientist, Robert Warwick, in Hawaii, discovered it. An image captured by an astronomical telescope at the University of Hawaii revealed a faint, slender streak moving across the sky at a steady pace each day. This day marked a historic moment as it was the first documented interstellar visitor. The discoverer came up with a fitting name for the entity and chose to call it Oumuamua, meaning a messenger from afar. Even though the discovery was made in Hawaii, it ignited a worldwide initiative to observe the object through telescopes. It also captured the attention of astronomers from the SETI Institute, who eagerly participated in studying the object. They also expanded the search further, hoping to find any extraterrestrial signs. You know, this object might just contain some advanced technology. What does Oumuamua appear like? You may wonder. Some describe it as a reddish, cigar-shaped rock. Its elongated form is nearly 4 meters wide and about 10 times longer than it is wide. Thus, this description exceeds that of any asteroid or comet in our solar system. However, some still suggested that Oumuamua was either an asteroid or a comet. An asteroid is a small rocky body orbiting the Sun, while comets are large entities composed of dust and ice orbiting the Sun. Oumuamua was traveling at a speed of 196,000 miles per hour, which means it is over 100 times faster than a bullet. This startling revelation further distinguishes it from what we can identify in our solar system. Whether it is an asteroid or a comet, let's attempt to differentiate between the two phenomena. Comets consist of ice, while asteroids are rocky. Scientists initially thought Oumuamua was a comet, but later revised their assessment and referred to it as an asteroid when it zipped past the Sun. However, they still regarded it as an asteroid until measurements indicated a slight acceleration, suggesting it might be a comet. Yet, there's a caveat. Once more, the object accelerated far beyond their predictions. This scenario puzzled the scientists, leaving the question of what Oumuamua truly is unresolved. A notable feature of Oumuamua was its periodic brightening and dimming every 7.3 hours. This dynamic indicator suggested its rotation around its short axis. Such a pattern implies that it might not be a comet. It indicated a more solid and durable composition than the typically fragile, snow-like material of most comets. It appeared dark red, similar to how moons in the outer solar system are influenced by cosmic radiation. Wait a moment. Could Oumuamua be an alien spacecraft? We all know the Russians are capable of anything on Earth. They consistently compete with the US. Additionally, Oumuamua's color contains iron, as proposed by Dr. Mech, an astronomer at the University of Hawaii Institute. So what did they discover about Oumuamua, and has any satellite been able to trace it and predict where exactly it will collide? Various theories emerged to clarify Oumuamua's identity. Some believed it was merely a rock, while others suggested it was filled with gas. Yet, some experts astonishingly claimed that Oumuamua must be an alien craft. This raises the question of whether an alien ship is hiding somewhere while releasing a portion of it to explore Earth. But is that the truth? Let's delve deeper into the theories to uncover more. According to Dr. Mag, Oumuamua must have been ejected from a distant star following a supernova explosion. According to Elon Musk, it formed when two objects collided and merged. Astronomers were initially excited when they found that Oumuamua seemed to be directed toward Vega, the brightest star in the Lyra constellation. This star was known to have a debris disk. Through calculations, this object might have journeyed to its current location in roughly 600,000 years. However, the likelihood of it originating from Vega soon seemed implausible. This was because significant alterations were observed in its trajectory. Astronomers believe that Oumuamua must have encountered a new stellar system for the first time, given its motion around the Sun. This was comparable to the speed of neighboring stars. Nevertheless, it is possible that Oumuamua has been traveling through the galaxy for billions of years. Another theory worth noting proposes that Oumuamua is a fragment of nitrogen ice. According to researchers Alan Jackson and Stephen Desch from Arizona State University, Oumuamua might be a piece blown off a Pluto-like object by a massive impact. However, to align with this theory, Oumuamua would need to be smaller than initially estimated. Another hypothesis suggests that cosmic rays interact with surface ice in interstellar space, releasing hydrogen gas trapped in water molecules. This resulted in a supply of hydrogen gas locked within amorphous water ice. This theory comes from Darrell Seligman from Cornell University and Jennifer Bergner from Berkeley University. They proposed that Oumuamua received warmth from the Sun, altering the structure of the ice and propelling it forward. Well, this may hold true only if it was genuinely ice. But that's not the end. Astronomers A. Loeb and Shmuel Bialy from Harvard University proposed that Oumuamua could be a solar-powered spacecraft. That sounds intriguing. According to them, Oumuamua's various characteristics imply that it has an artificial origin, hinting at the possibility of extraterrestrial involvement. This adds weight to the theory that Oumuamua might be of alien origin. Undoubtedly, the appearance of Oumuamua supports the notion that it came from a realm beyond our understanding of the solar system. However, we cannot reach a definitive conclusion since its true size and shape remain a mystery, and no instrument has managed to capture an actual image of this object. Astronomers rely solely on its brightness and their understanding of how asteroids and comets reflect light to estimate its size. Yet, since no tail or coma has been found on the object, the comet hypothesis was dismissed. The comet theory also suggests that Oumuamua's apparent movement could be due to the force that freed it from a presumed parent body. However, repeated non-gravitational acceleration contradicts this assumption. Instead, scientists developed a theory involving sunlight. If Oumuamua is extremely thin, around 0.3 to 0.9 millimeters, its motion might be attributed to solar radiation pressure. They proposed that Oumuamua could be a light sail, a technology demonstrated in space missions like the Japanese probe and NASA's nanosail. These light sails utilize photons' kinetic energy to propel themselves through space. Consequently, they suggest that Oumuamua could endure a prolonged journey through interstellar space as a light sail. They estimated it could travel at least 16,000 light-years from its origin. Additionally, Oumuamua's trajectory closely aligns with a region of the Milky Way galaxy known as the local standard of rest, making it challenging to determine its origin. Well, we can't finalize this discussion just yet, so the question persists: what is Oumuamua and who controls it? What is its ultimate destination? The last sighting of it indicated it was exiting our solar system. Now we are being informed it is about to crash into our planet. But before we delve further into that, scientists attempted to comprehend Oumuamua's trajectory. Their discussions and plans are worth noting, as they clarify why they assumed Oumuamua would collide in 2 weeks. So let's get right into that. Scientists believed they should dispatch robotic probes with sails racing toward Oumuamua. However, this suggestion is currently impractical because the world has not developed a vehicle capable of undertaking such a mission. Perhaps in the future, as initiatives like Breakthrough Starshot are already progressing. Whether scientists reach Oumuamua or not, its visit can prepare the world for future encounters. Even though Oumuamua took billions of years to arrive at its current position, it's merely a fleeting moment on the cosmic scale. The Milky Way galaxy is approximately 10 billion years old. Therefore, Oumuamua could have passed through around 20,000 star systems. While this is just a modest fraction compared to the galaxy's 200 billion stars, nonetheless, it's a substantial number of cosmic encounters for Oumuamua. It would have stirred up dust and debris, allowing the stars to intermingle. Therefore, Elon Musk and other astronomers believe that Oumuamua is racing toward Earth. They even predicted that it would enter the Kuiper Belt this year. Despite this, no one has located Oumuamua. They only work with the information they can gather to ascertain its movement and potential arrival on Earth. But there's more to discuss regarding Oumuamua's trajectory, which scientists labeled unconventional. They noted a significant non-gravitational acceleration indicating that forces beyond gravity propelled its motion. Dr. Mech explained that several factors could account for this acceleration. She proposed 6 possible causes. The first observation was that comets experience outgassing. This is a common phenomenon in comets. Outgassing occurs when a comet approaches the Sun, causing its surface ice to sublime, transitioning directly from solid to gas. This process provides the comet with an additional push, altering its speed and rotation. Apart from gravitational influences, the change in motion resembles the behavior of Oumuamua, aligning with the forces observed in comets. As gas escapes a comet, it carries surface dust with it. However, Dr. Mech asserted that even if the comet lacked microscopic material, the potential presence of significant dust on its surface might influence its speed. This consideration kept the notion of it being a comet alive, though only regarding its movement. Furthermore, scientists observed viable wavelengths that made it difficult to detect significant dust particles. Therefore, no visible evidence of dust departing Oumuamua was recorded. The absence of gas-related signs was also perplexing. Meanwhile, scientists and astronomers expected a considerable amount of gas emission to affect Oumuamua's velocity. Unfortunately, all their efforts were in vain. As far as they could search, no CN gas was detected. Considering that comets in our solar system can retain a substantial amount of water, the strong upper limit imposed by the absence of CN indicated that Oumuamua was chemically unique, and that's if it was a comet at all. Astronomers utilized the Spitzer Space Telescope to observe Oumuamua for over 30 hours, attempting to identify its thermal characteristics. However, they faced challenges in their efforts. Dr. Mech noted that the thermal infrared tests detected heat emissions, but their observation didn't yield any noticeable outcomes. Interestingly, this fact can be identified even without any tests. They concluded that Oumuamua might be brighter than anticipated if it exhibits thermal behaviors similar to a comet. An object's reflectivity, or how much light it reflects, can reveal details about its size, composition, and shape. Despite all these theories and propositions, no one has managed to unveil the mysterious identity of this interstellar object. So what else did they uncover about Oumuamua? Is it perhaps more than we anticipated and thus a significant threat to Earth in 2 weeks? Initially considered an asteroid, later a comet, and even thought to be a possible alien spacecraft by some, a pair of American astronomers now believe they have resolved one of the space rock's lingering mysteries. Observations made during its brief visit soon confirmed that Oumuamua was on what astronomers refer to as a hyperbolic orbit, a boomerang-shaped trajectory indicating that the rock was not native to our solar system but merely passing through the Sun's vicinity and would never be observed again. But is this observation definitive? Would Oumuamua never be seen again? An intriguing phenomenon surrounding Oumuamua is its speed, which appeared to increase as the rock rounded the Sun. Large bodies, such as planets and stars, can provide smaller objects, including comets and asteroids, a gravitational boost that accelerates them. However, in the case of Oumuamua, which cruised at 54,000 kilometers per second, 3 times faster than an average solar system comet, these gravitational boosts couldn't explain the observed acceleration. If you recall, this was one of the theories that presented a significant challenge for scientists. This acceleration led many scientists to conclude that Oumuamua must be a comet rather than an asteroid. Comets in the solar system gain additional momentum from the water and dust that evaporate from their icy cores as they warm up near the Sun. These comets, however, are famous for their spectacular tails that illuminate due to the outgassing process, and Oumuamua showed no signs of a tail. Numerous scientists have attempted to explain the mechanism behind Oumuamua's acceleration, but all proposed ideas have exhibited substantial gaps. As we continue to explore these enigmas, the urgency of understanding Oumuamua's trajectory and identity intensifies with its anticipated approach to Earth. The implications of this interstellar visitor are profound. Are we merely spectators of a cosmic anomaly, or does Oumuamua conceal secrets that could redefine our understanding of the universe? The answers may reside in the collaborative efforts of scientists worldwide as they strive to unravel the mysteries of this strange visitor before it reaches our planet.